After looking at what consumers are able to purchase, that is, the constraints they face, now let's try and theorize what they are willing to purchase, what they want. Now in this case we're going to conceptualize wanting or willingness to purchase something, or the desire for something, in terms of preferences, what people would prefer to have. Okay, so in doing that, we need to, in constructing our theory, we need to make a few assumptions to get things going. Now the assumptions in this case, more so than the in the construction of a budget line or a constraint line, these assumptions that we're going to make are somewhat unrealistic. But nonetheless, it's a starting point. And after we've made those unrealistic assumptions, later on, if you want to, you can start relaxing those assumptions and see what outcomes you can derive from that. But let's start with some basic assumptions. The assumptions are, first, what we'll call the completeness assumption. And this says that our consumer or our buyer has perfect knowledge of all of the options available to them, all the possible combinations of goods which they could choose between. The second assumption that we'll make is a non-satiation assumption. That is to say, our consumer will never be completely satisfied. Our consumer will never reach what's theoretically known as a bliss point, which is superior, a combination of goods which is superior to all others. We're not going to assume that. We're going to assume they never get to that point. That is, they will always want more of a good. This assumption would only be violated in special cases, which we might look at a little bit later, such as cases where we would be thinking about what are called bads, that is, things that give people discomfort or pain or unhappiness, and also useless things, things that don't give you pleasure or pain, happiness or sadness, satisfaction or dissatisfaction at all. They're totally irrelevant to you. So aside from those special cases, we're going to assume that our consumer or our buyer always wants more of goods. And the last assumption that we'll make is a transitivity assumption. The transitivity assumption simply says that our consumer's preferences are logically ordered. That is, there is no internal logical contradiction between any of the preferences that a consumer will express. We'll see what that means in a little bit later, but for now, let's move on. So here we have our consumer, Tina, and she's got a choosing between soft drinks and movies per month, and there are obviously quantities of soft drinks and quantities of movies in different combinations which she could conceivably want. Let's say that there are certain combinations of soft drinks and movies which Tina finds equally satisfactory, derives equal satisfaction from, is equally happy with. And let's call all of these combinations expressed on a curve an indifference curve. Indifference because Tina doesn't care, in a sense, doesn't care which combination of quantities of soft drinks and movies she consumes on this curve, because they all give the same amount of satisfaction or happiness. So, for example, at point C, Tina would be consuming 6 soft drinks and 2 movies, and at point G would be consuming, well, approximately 2 soft drinks and 6 movies. Maybe a bit less in terms of soft drinks. But the point is that Tina derives the same amount of satisfaction from either one of those points. She is indifferent between them. And all the other points on this indifference curve. So that's our first idea. Anything less than any of the combinations on that indifference curve is less preferred to all or any of the points on the indifference curve. And all of the combinations beyond this indifference curve she prefers more of. She prefers rather than any of the points on the indifference curve we've noted here. Something we can say about this particular indifference curve is that it has a certain shape to it. We can see it's downward sloping, and it's convex to the origin. When we think about moving from one combination to another on this indifference curve, so Tina remains equally satisfied, we're thinking about substituting some of one product for another. For example, say Tina went from choosing 10 movies per month and a tiny bit of soft drink to 8 movies per month. In that case, in order to remain equally happy, that is to remain on the indifference curve, Tina, in giving up some movies, would have to be compensated, so to speak, with some additional soft drink. Just a little bit of additional soft drink to remain equally happy. But if she gives up another 2 movies, goes from 8 to 6, she would want to be compensated with a bit more soft drink than before, some additional soft drink, greater marginal soft drinks. And if she decreased her movie consumption down by another 2, from 6 to 4, she would, to remain equally happy, require a still larger additional amount of soft drinks to remain equally happy, and so on. What we can see here is with this marginal rate of substitution, that is, substituting movies for soft drinks, or substituting movies with soft drinks, is that this marginal rate of substitution is, in absolute terms, increasing. In fact, we can see there that this marginal rate of substitution, the rate at which you give up, you need to be compensated with one thing for giving up another, this marginal rate of substitution, can actually be measured somewhat inaccurately here by a slope. So if we took the slope along this indifference curve at the bottom here, that is the rise over the run, we can see that the slope is very slight. Remember, it's a negative slope because it's downward sloping. That is, we've given up 2 movies in exchange for a quarter of a case of soft drink. So our slope, or our marginal rate of substitution, is very slight. It's negative 0.125. But if we went to the other end here and measured the slope between these 2 points, moving from 4 movies to 2 movies, we can see the marginal rate of substitution is much higher in absolute terms. We've got the rise over the run. So we've given up 2 movies, and in exchange, in order to remain equally happy, Tina would have to be compensated with 3 soft drink cases. So our marginal rate of substitution is negative 1.5. That is, for 1 movie, Tina would have to be compensated with 1.5 cases in order to remain equally happy. Of course, this particular indifference curve is not the only possible indifference curve there. There are many other combinations of soft drinks and movies that Tina would have preferences with respect to. So, but before we go on to that, what if we wanted to talk about the marginal rate of substitution at a particular point? Say at point C. How do we find the marginal rate of substitution at that point? Well, what we can do is draw a line of tangency at point C. When we do that, we can then simply calculate the slope of that straight line, and that will give us the slope, or the marginal rate of substitution, at point C on that indifference curve. So in this case, it's negative 2. So note that the marginal rate of substitution for this at this particular point is going to be negative, because we're talking about a negatively sloped curve. What about the slope at point G? Well, again, we'd find a tangent to it, and then calculate the slope for that straight line tangent at point G. So the slope of this line is half. So again, remember that's actually negative half, and it means to give up 1 unit of movies, Tina would need to be compensated with half a unit of soft drinks at that particular point G. Okay, so we know about the slope of an indifference curve, and we can see for this kind of indifference curve that it has a negative slope, the marginal rate of substitution is negative, and we can see that in absolute terms that negative marginal rate of substitution, or that marginal rate of substitution, decreases as we move downwards along the indifference curve. Now, as I was saying before, there's obviously more than one indifference curve that could exist. In fact, there's an entire, if you like, surface of indifference curves. In fact, the whole area is a surface, and we've simply selected out certain lines on that surface, much like on a topographical map, where we're drawing out the, if you like, the ever greater climbs as we move up a mountain, for example. So what we can see here is that there's indifference curve I0, and for all of the particular points, all the particular combinations of soft drinks and movies, Tina is indifferent between them. But remember our non-satiation assumption that our consumers always want more. So we can see that Tina would get a certain amount of satisfaction from any point on that indifference curve. But by moving to the next, in inverted commas, higher indifference curve, we can see that Tina would be able to consume more of both soft drinks and movies. And we assume that Tina would prefer more of both rather than less of both, which means that every point on this indifference curve will be preferred to every point on the lower indifference curve, which gives less satisfaction. And also, we can see for indifference curve I2 that this indifference curve gives more, enables our Tina is able to consume more of both again than I1, and therefore we would say that at this point and every other point on this indifference curve, Tina derives more satisfaction and therefore prefers to be on this indifference curve compared to every point on the lower indifference curve, and certainly every point compared to the indifference curve below that. So we can see, for example, that points C and G give Tina exactly the same amount of satisfaction. Tina is indifferent between C and G. But Tina would prefer point J. J is on a higher, in inverted commas, indifference curve, and therefore gains more satisfaction from J compared to either C or G, and certainly gets more satisfaction than any point on the lowest indifference curve we've drawn here, I0. Remember, these are just samples of indifference curves. There's actually millions of indifference curves there. We just haven't drawn them all. On the previous graph, we've got these neat indifference curves, everything's going well, and we would say that all of the assumptions that we've posited hold. That is, Tina knows all of the options that are available to her, and she prefers more options to less. Are her preferences transitive? We would say yes, her preferences are transitive. And a way of illustrating that is to look at a situation where her preferences would not be transitive. And that's here. So imagine we've got these two indifference curves like this. So we've got indifference curve A and indifference curve B. Let's say initially Tina has chosen point A, that is 6 soft drinks and 2 movies. Now the definition of the indifference curve means that at this point here, point A star, Tina would be equally happy or equally satisfied, would be indifferent between A and A star. That's what an indifference curve means. Okay, next step. What about point B star? At point B star, would that be preferred to A star? Well, the answer would have to be yes, and Tina would prefer point B star to point A star because B star gives more in total, gives more rather than less, and Tina would prefer more than less. So it means that point B star generates greater satisfaction than point A star. So B star is preferred to A star. And therefore, since this is on a particular indifference curve, it should be the case that every point on the indifference curve IB gives the same level of satisfaction. So that would mean point B here should give the same level of satisfaction as B star. However, now think about comparing A and B by themselves. According to one of our assumptions, Tina would prefer more to less. Now, if Tina prefers more to less, we can clearly see that A gives her more soft drinks for the same movies compared to B. Gives less soft drinks for the same movie. So Tina should prefer A to B. Okay, now we've got a problem. She prefers A to B, which means she prefers to be on indifference curve A rather than indifference curve B. But when we went back down here, we figured out that she must prefer indifference curve B to indifference curve A. This is a logical problem. It's intransitivity. Her preferences are not transitive. At this low level, she prefers A to B, but at this level here, she prefers A to B, but further along, she prefers B to A. She can't prefer A to B and then B to A. Something is going wrong. There's some logical incoherence here. It's generated by the fact that the indifference curves are overlapping. As long as the indifference curves are not overlapping, then Tina's preferences will be transitive, unlike in this particular case. From now on, we're not going to draw any graphs like this anymore, any indifference curves or indifference maps like this anymore. All the indifference maps from now on will have indifference curves which do not overlap. Okay, what we've been looking at as an example are obviously the soft drinks and the movies, and what we've assumed implicitly here is that soft drinks and movies are substitutes for each other. They're not perfect substitutes. They're imperfect substitutes. We know they're imperfect substitutes because the marginal rate of substitution changes as we move along any given indifference curve on the map, on an indifference map. If we made the two products that we're looking at more substitutable, that is, closer substitutes, then the indifference curves would be less curved. They would start to get flatter, or we'd say they would start to get straighter, more accurately, until we got to, say, for example, an extreme case of the two products on each end being perfect substitutes. In that case, the indifference curves would be straight lines. As we can see here, in this example, we've got marker pens from the local supermarket and marker pens from the university bookstore. Let's say, from the perspective of the consumer, the marker pens from either place are identical in every respect. They're perfect substitutes. In which case, for example, our consumer would be equally happy purchasing 6 markers from the supermarket or 6 markers from the university bookstore, or 3 markers from the supermarket and 3 markers from the university bookstore. Our consumer would be indifferent between them. Our consumer would be happier or would prefer to have more rather than less, so we could shift up to a higher indifference curve further away from the origin, a higher indifference curve in which our consumer would derive greater happiness or satisfaction. So our consumer would be equally happy with 8, more happy than having 6, but equally happy with 8 markers from the supermarket or 8 markers from the bookstore, or 4 from the supermarket, 4 from the bookstore, and so on. But our consumer would be definitely happier with 8 rather than 6 at any point on this indifference curve. Don't confuse this with budget lines. This is representing our consumer's preferences. Now that's if you make the two goods more and more substitutable. But what if we made them instead more and more complementary? When we talk about complementary goods here, we mean goods that, colloquially speaking, go together. That is, in order to enjoy one type of good, it's necessary to buy the other in some quantity or other. And a simple example of that would be left-running shoes and right-running shoes. These are perfect complements. Our consumer derives a certain amount of happiness or satisfaction from one left-running shoe and one right-running shoe. and derives greater happiness from 2 left-running shoes and 2 right-running shoes. But what if, so we can say the preferences are the consumer prefers to be on the higher indifference curves rather than the lower indifference curves. And our consumer is apparently non-satiatable. A consumer could want more and more both left and right running shoes. But let's go to the first indifference curve here. We can see that if our consumer had 1 right running shoe, what if she had an additional right running shoe? An additional left running shoe. Would our consumer be happier? No, because that additional running shoe wouldn't give her any additional satisfaction because it's a left running shoe by itself. It's useless by itself. And the same for if you had 1 right running shoe and 5 left running shoes. You wouldn't be any happier than having 1 right and 1 left. And so we would have an indifference curve which would be vertical from this saddle point here and horizontal from this saddle point here. That is, it's the same story with if you only had 1 left running shoe and you had 5 right running shoes. It would be the same. You would get the same amount of happiness as having 1 left and 1 right, because the other 4 are useless. Okay, the point here is that the marginal rate of substitution on an indifference curve will change or vary depending on the types of goods that we're looking at. If we're looking at perfect substitutes, the marginal rate of substitution will be constant. If we're looking at imperfect substitutes, the marginal rate of substitution will diminish in absolute terms, will diminish as we move downwards along it. If we made the indifference curve, if we made these 2 substitutes even less substitutable, we could then we would have an even more bowed or even more convex to the origin indifference curve. And the most extreme case is this, is the perfect complements, where they're L-shaped. One little thing for you can have a little puzzle over. Imagine that on the horizontal axis we didn't have a good, that is something that people want more of, but what if we had a bad instead, something that gives displeasure or unhappiness or pain? What would an indifference map look like in that case? We had a good on one axis, say soft drinks, and on the horizontal axis we had, say for example, garbage. What would that indifference curve, what would the indifference map look like in that case? And what if we were talking about, on the horizontal axis, we had something which was totally useless? So we had, for example, marker pens on the vertical axis, and we had something totally useless like, I don't know, what's something totally useless? A styrofoam statue of Jedwood. There, that's totally useless. So what would the indifference map look like in that case? All right, that's something for you to puzzle over.